center 0, 0. Sorry, I'm ahead of myself here. This is paper 2, 2017. And the circle C has center 0, 0 and radius 5 units. Write down the equation of C. So that's a mathematics tables book question. So we go to page 18 or 19 and we look up equation of a circle, and we're going to use the formula x minus h squared plus y minus k squared is equal to r squared, and that's on page 19. So we then go x minus 0 squared plus y minus 0 squared is equal to 5 squared, and they will want to see you squaring this thing here out. So that's going to give us x minus 0 squared plus y minus 0 squared is equal to 25. So that's our answer. They won't expect you to go any further than that. They might expect you to write down x squared plus y squared equals 25, but I think they'd be happy enough with this line here, I would imagine. Okay. Next question. The diagram shows a semicircle which is part of C. Okay. The point P minus 4. Okay, this guy here, and k is greater than 0, is on the semicircle. Find the value of k. Find the value of k. Okay. So I know that my x value for k is minus 4. So into this equation here, or into this formula here, I can throw in a minus 4. So minus 4 squared plus k squared, because k is the same thing as y, is equal to 25. So that's this line here is this line here. So that's going to be 16 plus k squared is equal to 25. So k squared is equal to 25. Take away 16. So k squared is equal to 9. So k must equal to the square root of 9. So k must equal to 3. That seems pretty, that seems okay, yeah. So the coordinates of P are now minus 4, comma 3. And that seems to be good because we're up there. Yeah, I probably should have talked about this square root here, because there's another answer, which is the square root of 9, right? So 3 by 3 is 9. But also minus 3 by minus 3 is also 9. So the answer here could be or minus 3. But because the way the circle was drawn, we knew k had to be positive. So we're going to disregard that guy there. Yeah. Show that the triangle ABP is a right angled at P. So if we were to connect this point here onto this point here, and we were to connect this point here onto this point over here, and this point here onto this point here, we have to show that there's a right angle in there, and that angle there is a right angle. So we have to show that that red triangle is a right angle triangle. So we could do this a number of ways. I think when I tackled this question before in class, I tackled it using distances. So we said that they agree with Pythagoras' theorem, but probably the nicest way of dealing with it is to use slopes. I think a few of you tackle it that way yourselves, so we'll try it this way now, this time. So let's take a look at the slope of AP. Let's work that out. So we're going to use the formula m is equal to y2 minus y1 over x2 minus x1, and we should always label up our points. So A is what? Minus 5, 0, and P is minus 4, 3. So let's label them up. Let's call this guy here x1, y1, x2, y2. So that goes into the formula 3 minus, sorry, wrong formula. I have distance on my mind. So that goes into the formula 3 minus 0 all over minus 4 plus 5. Are we okay with where that plus 5 comes from? Okay, this guy here. Yeah, so it was minus 5 to give us plus 5. So that's going to equal to 3 all over 1, which is equal to 3. So that's the slope of this guy here. So slope is equal to 3. Let's work out the slope of this chap down here then. So we're now going to go for P, which is minus 4, 3. And we're going to go for b, which is 5, 0. So next job will be into the formula, label them up, maybe x1, y1, x2, y2. So we can now have 0 minus 3 all over 5 plus 4. So that's going to equal minus 3 over 9, which is equal to minus 1/3. So the slope of this guy here is minus 1/3. And we can put in a little note, flipped and opposite sign. Therefore, perpendicular. Perpendicular. Sorry, my handwriting is very bad because I'm writing on the iPad's glass, so it's very slippery. But that says flipped and opposite sign, therefore perpendicular. So when we have this idea of the 3 here and the minus 1/3 here, we can see that that 3 is technically 3 over 1, and that's minus 1 over 3. So when we flip the fraction and change the sign, well then we have perpendicular lines, and we should know that, okay? So on to part B. Find the area of the region which is inside the semicircle but outside the triangle ABP. Give your answer in square units corrected 2 decimal places. Okay, so let's work out the total area of the circle first of all. So let's work out this area in here. So that's going to be the first thing we're going to work out. And that's going to be, well, it's the area of a circle divided by 2. So it's going to be pi r squared all over 2 because it's half of a circle. So it's pi r squared over 2 because it's half of a circle. So that's going to be the red area. So that area is equal to pi, and we're told the radius is 5, so it's 5 squared all over 2. So that's equal to 12.5 pi, I think, if we put that into our calculator. So the area of the red part is 12.5 pi. Now let's have a look and see if we can work out the area of the blue part. Well, what shape is the blue part? It's a triangle, so we're looking for the area of that triangle. So it's going to be a half the base by the perpendicular height. So the area is going to equal a half of, well, the distance from here all the way over to here must be 10 because it's 5 from there to there and it's 5 from there to there. So it's going to be 10. And the perpendicular height, well, the perpendicular height is the distance from here all the way down to there. So that distance, that's the perpendicular height. And that corresponds to what k is. And we know that k is 3. So it's going to be 3 because we know that k is 3. So A, have I gone a different colour blue? I have. A is equal to 5 3s, which are 15. Okay, now, what question were we asked again? Which is inside the semicircle, but outside the triangle. Okay, so we're going to have to go for 12.5 pi, and from that we're going to subtract 15. So imagine I'm actually taking this wodge of area away, and I'll be left with just this red area out here. Sorry, I didn't go far enough with the blue. I'm taking all of this away. So I'm taking the blue area away from the red area to be left with this new red area out here. So that was the strategy there. So that was question 2 dealt with.